Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Good morning. Today we will do some problems on relative motion analysis on the velocity part. This is going to be your tutorial 4. So let's try this first question. The first question shown here is the wheel. This wheel OB is rotating 8 radian per second clockwise, and the wheel is driving the link AB, okay, and which in turn drive the collar A on the horizontal rod. So the collar will move horizontally. At the instant shown in the figure, determine the velocity of collar A. So what do we have? We have the angle of OB, theta 30 degrees from the horizon, and the angle of A, collar A is 60 degrees, AB is 60 degrees from the horizons. And then we have some vectors here. So what should we do? So as you remember before, the first thing we need to do is we put the coordinate system. Okay, so let's put the coordinate system. So we can put our xy here. Right, so that's our x and our y. Second, we do the kinematic diagram. That is, we want to find the important figures there. So we change the color to black. So what do we have? We have also omega OB. Yeah. So what's that? That is xy z. So it's minus 8k. I hope by now you know why it's negative k direction. Radian per second. What do we have? We have a VA vector here moving in the horizon. So I can write down here VA equals to magnitude of VA. The direction is I. What else do we have? We have an omega AB. So this is omega AB. So I can assume that omega AB is equals to, the vector is amplitude omega AB in the positive k direction. I'm assuming that, yeah. And what else do we know? We know that position vector A relative to B, position vector A relative to B, we might need this. So that is 500 cos 60. So cos A relative to B, 500 cos 60 I. A is to the right of I, and A is to top of I. So, and then 500 sine 60 J. What else we have? We have position vector B relative to O. B relative to O equals to B is to the left also, 150 negative cos 30 degrees I, and B is top of O, so positive J, 500 sine 30J. Anything else that we have? So that's basically the data that this is position vector B relative to O, and this is our position vector A relative to B. Okay, so what else? So we know we can draw this position vector A relative to B. So if you look at the way I draw the position vector A relative to O here, is equals to this one. So I can now write position vector A relative to O equals to position vector A equals to position vector B plus position vector A relative to B. So that we can transform this equation into the velocity equation. Velocity of A equals to velocity of B plus velocity of A relative to B. Now, we know what VA is, but we just want to know omega AB. So we can, but we know VA to be equals to omega AB. Omega AB, we know that is omega AB K here. So here is omega AB K. So omega AB K cross position vector A relative to B. Okay. So that is the value here. Let's draw different colors. A relative to B is here. So you can put it yeah. So omega AB. Yeah. And we can now substitute all the values. So VA, so that VA, VA. So I'm going to rewrite that again. VA equals to VAI. VAI equals to VB. VB, we know that omega AB. Okay. Cross. Position vector A relative to B is 500 cos 60 degree I plus 500 sine 60 degree J. Yeah. A relative to B. Yeah. And then kita position AB, this is VA relative to B, this plus VB. Oh, VB is omega AB. It's 8K or minus 8K plus minus 8K cos minus 150 cos 30 degree I plus 150. This is not 150. This is 150 sine 30 degree. Yeah, from there you can get your answer. So the answer is given. You can do that on your own. I wouldn't solve it here. So we can solve that problem. So let me clear this VA. So you get VA equals to, if you do the I part, you will get VA equals to 0.6 plus 0.433. 6 plus 0.433 omega AB. This is for the I part. And then for the J part, you will get omega AB 0 equals to 1.0 1.039 minus 0.25 omega B. So that gives you the answer. Omega AB equals to 4.6 radian per second. That's the answer that you want. And from there, I'm moving here. And then you get VA equals to 2.40 meter per second. Okay, so I hope you can follow the way it's being done. Okay, right, let's move to the next tutorial. Question. So, question 2. Question 2 is question 2 shows the link AB is a crank slider mechanism. Like link AB has angular velocity of 6 radian per second counterclockwise at the instant when theta equals to 45 degrees. So that's theta is missing here. So let me put theta. And phi equals to 30 degrees. Determine the velocity of the slider block C. So theta 45, 5 is 30 degrees. So the question asks you to determine the velocity of the slider block C. Let me. So this is what we want a V. Right. So the first thing we'll do, I don't have to write it down. The first thing we'll do is we draw the coordinate system. So this is our X and Y. The next thing is for us to draw the kinematic diagram. So we know VC is here. Let's say this is VC. We know this is omega BC. So we can write down omega BC as we assume omega BC equals to the omega BC K. As remember, this is an assumption. VC, we know VC is moving in the I direction, so we can put I directly. There's no J component for the VC. The piston cannot move vertically, it can only move in the horizontal slot. We know omega AB. Omega AB is counterclockwise 6, and it is 6K, yeah? Positive K, radian per second. And then what about omega AB? We already done that. Omega BC done, omega AB done. So we want to find the position vector. So I will draw the position vector using the orange color. So this is position vector. Okay. So this is position vector C relative to A, position vector B relative to C, and this one is position vector B relative to A. So we can write the position vector questions. So position vector C relative to A equals to position vector B relative to A plus position vector C relative to B. So position vector C. And therefore we can write from there the velocity question. So V C relative to A. Let me go like this. So VC relative to A, because A is not moving, so we can write this as VC equals to VB relative to A. A is not moving, so we can remove A. Okay, VB plus VC relative to B. But we know, but there's a but, VC relative to B equals to omega CB K cross position vector C relative to B. That one we know, so let's plot this. Okay. What else do we know? We know we need now the position vector C relative to B. So let's write down position vector C, position vector C relative to B. It is 500 cos 30 degrees to the right, so I positive, and it's below B, so it's minus 500 sine 30 degrees J. And what about B relative to A? Position vector B relative to A is 200 cos 45 degrees I plus 200 sine 45 degrees J. So that position vector B relative to A. So now we can now put all the values that we have here. Remember, as you know, we know that VC equals to VCI, so we do that. So we can now write the equation here. We know that is VC equals to VCI equals to VB. VB is equals to omega AB. What is omega AB? Is 6K. Omega AB is 6K, so 6K VB. I have to talk about, I have to put here VB. Sorry. So VB is where do so 6K cross the position vector is, let me use symbols last now. Let me use symbols here. So VB is omega AB cross position vector B relative to A, because it's a, and then VC relative to B is omega BC K position vector C. So you know the value of things here, omega AB. Let me just show where the values are. Omega AB is here. So you can found that value here. Position vector B relative to A is here. So that one goes here. Omega BC is unknown, and position vector C relative to B is here. So you then put this value here. So that would allow you to, so if you solve this and solve by parts, for the I part, you will have VC equals to minus 0.8485 plus omega 0.25. And then for the J part, you can solve it. 0 equals to 0.8485 plus 0.433 omega. From this both, you will get the answer that you want. Omega equals to minus 1.96 radian per second. This is for the omega BC. And VC will get 1.34 meter per second. Okay, so that's the answer. It's minus 134 meter per second. Okay, so let's move to the next question.
Alamak, dia bila habis bateri dia mula beragam. Boleh je. Jasmine tak sedap. Chamomile weh. Tengok. Jasmine ke chamomile? Boleh. Lawak. Tak nak makan, bawa pergi surau. kat lampu tu. So sine 30 degrees. In order to solve this, I've constructed this diagram, okay, to show that I need this angle phi, and I use the sine relationship, sine law, to find what phi is, and I can calculate phi to be 8.34 degrees. From there, I wanted to find each of the position vector B relative to A, and A is not moving, so it's equivalent to position vector B equals to 1.45 sine 30 degrees I plus 1.45 cos 30 degree J, and I got this number here. And then I use the same approach to find position vector C relative to B. I know what my phi angle is. The angle is 8.34 degrees. So I've substituted minus 5 is to the left, and it is going up, and it got 0.725 plus 4.947J. And from the displacement equation, position vector C equals to position vector B relative to A plus position vector C relative to B. So, and from there I got the velocity equation, VC equals to VB plus VC relative to B. I know VC is 300 going upwards, and I can calculate VB equals to omega AB cross the position vector here of B relative to A, 0.725I plus 1.256J. We've done that here. And similarly, we get this answer, and I put it as number 2. And then VC relative to B is omega BCK cross position vector C relative to B. We've calculated that to be minus 0.725I plus 4.947J. And we got this answer here, 0.725 omega BCJ and minus 4.947 omega BCI. And we rewrite again the equation VC. We know what VC is. Put VB here, VC relative to B, and then find the I component and J component. The I component is 0. There's no, for the C is only moving upwards. So 0 equals 1.256 omega AB and minus 4.47 omega VC, and similarly J is 300 equals to 0.75 omega AB, and then we solve this equation, we got omega BC equals minus 83.798, meaning that omega BC is in the opposite direction. So we can rewrite omega BC as minus 83.798. So when we transfer that to the next here, so we know that omega BC equals to minus 83.798 K radian per second. What we wanted to know is the velocity of G. So if I were to draw the position vector of G, I can draw it here, yeah? So I'm using the orange color. So G is here, equals to here. This is A, B, G. Yeah. So I can say that position vector B equals to position vector B plus position vector G relative to B. That's one way of doing it. I also can use a different sets of position vector. I can use another position vector which is like here. This is position vector C equals, or here, here and there. So I can also I can say that position vector C equals to position vector G relative to A plus position vector G relative to C. Sorry, I rewrite again. Position vector C relative to G plus position vector G relative to A. So and with that I can use that equation to write down from this. I can write down the equation of VC equals to VC relative to G plus VG relative to A. Okay, and because A is not moving, I can slash that and I say that this is equal to VC relative to G plus VG. The question asks us the velocity of the center of gravity, so we wanted to find VG. So that's our main concern, is to find VG. Do we know VC? Yes, we know what VC is 300. So we know VC is, this is 300J. Do we know what VC relative to G is? VC relative to G is omega CG cross position vector C relative to G. Okay, this might be a bit challenging for you guys, but we have done that before. We position the velocity of any point relative to the point on the same body is equivalent to the angular velocity of the whole body cross product with the position of vector of the wanted point relative to the any point on the system. So this is relative to CG. So plus VG. This is unknown. So we need to find. We know that, but omega CG is equivalent to omega BC. It's the same thing on the same body. So it's minus 83.798 K radian per second. What about position vector C relative to G? Can you find position vector C relative to G? Remember, we know this angle. So it's so I need to clear this from the so many sketches. Yeah, so these sketches, these sketches. So I want to remove these sketches too. Cannot remove these sketches. So I want to find the position of what color can I use? I can use black. So I want to find this position. This is C. So the vector is, we know what this angle is. It is phi. We have done phi before. What is phi? It is 8.34, I think. 8.34. 8.34 degrees. Yeah. So if, yeah, it's 8.34 degrees. So C, so from there I can draw, if I can draw this angle here, something like this. So this is 8.34 degrees. What is the length? The length is 5 minus 2.75. This is 2.25. So we can find this component and that component. So C relative to G is 2.25 sine 8.34 degrees. I is a negative to the left. C is relative to the left of G, VC. Yeah. And then 2.25 is to the top, so cos 8.34 degrees G. Yeah, so this is the so from there, so we have our vector position of C relative to G is minus 6128 I plus 226 is some zero. This is 0. Wow, this is 0.128 I plus 2226J. So we can find the relative velocity of C VC relative to G equals to omega CG. Omega CG we know is minus 83.798 here. Yeah, so omega CG is here. I'll put it here. Yeah, cross position vector minus 1.28 I plus 2226J. Okay, so we calculate VC relative to G, omega AB, omega BCK is omega CGK times cross the position vector of C relative to G minus 0.128 plus 226, and we got 10.726J. K cross J is minus I, and we've got minus, so it got positive I, so 186.53. That is 0.53 I. So that is the speed of G relative to C. So now we can rewrite that again. So I'm going to use the top part here. Maybe I can remove this omega VC2. So I'm going to rewrite again the equation. So that equation VC. So I'm going to use this equation here. So let me put this orange thing. So I'm going to use that equation here. So we know what VC is. VC is 300J. So it's 300J equals to VG. VC relative to G is 10.726J plus 186.53I here. Okay, plus VG. VG is the unknown, so we check by parts. So we'll check the I parts first. Okay, so for the I parts, 0 equals to 186.53. Also there is a VG component in the I, so VG. So Vg equals to negative 186.53. Okay, so that's the I component. For the J component, there's a VGJ. So J is 300 minus, for the VGJ, this is VGI. The VGJ is 300 equals to 10.726 plus VGJ. Yeah, so VGJ component is equals to 300 minus 7.26. That's equals to 289.274, and this can write as J, and we can write this as I. So that is the answer for the VG. So that's the way to do it. I might have made some mistakes along the way. You can find the mistakes, but the number seems to be right. The approach seems to be right. The only mistake that we might have done is maybe in the vector operation or the position vector and so on. So that's the way how you can find VG. I think the whole issue here is to know how to relate these two things with that kind of equation. Yeah, this needs a bit form of deeper understanding from the commonly where we find the endpoints anyway. I'll try to revisit this later on. We came across the same problem. Okay, thank you. That's all I wanted to say for this tutorial. It's been a long one. Thank you for your attention. See you in the next lecture.